Good afternoon, Saripam, friends, and everyone who are watching. Welcome. This time, me and my team will be presenting our project about automated chemical disinfecting chamber using Wemos D1R1 microcontroller. Before we go anywhere further, let us introduce ourselves.
My name is Immanuel Krisliangi. I'm from 12A3, number 13.
I'm Stefana Felmuljadi from class 12A1, number 27.
And my name is William Nathan Thomas. I'm from 12A2, number 28. Now let's begin. The first part will be the introduction, which will be explained by my friend Noel.
Thank you, Wilnut. So the first part is the background of this project. Currently, we are living in a pandemic situation where lots of daily activities are limited. It is risky for us to leave our houses due to the COVID infection. Shopping is one of the most important things to do in a daily basis, and referring to the current situation, we all agree that going to the grocery stores is not the best method to go shopping. The safest way is through online platform. However, we cannot ensure whether the courier are 100% healthy and the hygiene of the package itself is not guaranteed. To reduce this risk, we tried to design a simple automated chemical disinfectant chamber and it will be put on the fences. Hopefully, we can have less physical contact with the courier and at the same time, it will spray the package with chemical disinfectant. Okay, next. So, in this project, we divided into two groups of questions. The first one is, does it work? And the second one is, what are the implementation of the STEAM learning system in making of this tool? STEAM basically is science, technology, engineering, art, and mathematical aspect. Next slide, please. So the second part is about the basic theory. Okay, next. In this research, we have 5 theories that we would like to explain each of every one of them. They are disinfection, I/O pins, programming, sensor, and microcomputer or microcontroller. Okay, next. The first one is about disinfection. Basically, disinfectant means chemical compounds to prevent contamination of organisms. And the process of disinfection is called sterilization. Sterilization means a treatment to clean materials from microorganisms. Nowadays, there are a lot of development on sterilization process, and one of them is disinfectant chamber. These technology are built to ease people and to optimize the process of sterilization itself. Okay, next slide, please. And the second one is sensor. Sensor is a crucial part in this project. Sensors are basically the computer sense which make the device works automatically. There are many types of sensors as you can see here, but in this case we use ultrasonic sensor in our project. Basically, the sensor shoot ultrasonic waves, then those waves will bounce through the object and return back to the sensor. Each distance produce different time length for the sensor to read it. Okay, next. And then the third part is microcomputer or microcontroller. This part will be explained by Stefan. Thank you.
Thank you, Noel. Now I'm going to explain about microcomputer or microcontroller. Microcomputer or microcontroller is essentially the same thing as computers, but it is smaller in size. Microcontroller also consists of CPU, memory, and I/O pins. Next slide, please. I/O pins. IO pins is often referred to as GPIO or General Purpose Input-Output pins. These pins are used to generate electrical output or read electrical input. Next slide. In this project, we use Wemos D1i1 microcontroller. And the Wemos D1i1 microcontroller is programmed using C++ programming language. And the program itself is divided into two major parts. The first part is the void setup, where we define the pin numbers and the library that we want to use in our projects. And the second part is the void loop, where we define our main function for the project. Next slide. In the third part, I'm going to discuss the method of the manufacture. Next slide, please. In the making of this project, the making is divided into two main parts. The first one is the coding, and the second one is the device building. In the coding part, we first write down the code so the project and the chamber itself can function as we want to. And the second, we also calibrate the sensor so it has the right measurement to detect the object inside the chamber. In the second part is the device building. First, we structure the prototypes of the chamber, and we also design the electrical components and diagram so it can work as it should. The final part, we apply the electrical components to a fixed framework, and then we can done testing in it. Next slide, please. These are the picture of our first and second prototypes. In the first prototypes, we use cardboard, and it's very flimsy and not waterproof. In the second prototypes, we use a denser cardboard. It is still flimsy, but it is waterproof because it is laminated with duct tape. Next slide. After a careful consideration, we decided that our final products will be produced by an acrylic sheet that is cut into pieces and structured to make a chamber. Our electrical component will also be implemented in those acrylic sheets. This is the photos of our final products, where the electrical component part is on the right side of the chamber. Next slide. These are the code of our projects. In the first part, on the left side, is the function to detect and measure the distance of the object inside the chamber. And then below it, we use the relay to trigger the 12-volt pump to spray the object. And the last one on the right side is the function to send a notification to the smartphone app if the object has been sprayed. Next slide. This is the flowchart of our projects and the working methods. If the sensor reads the distance more than 35 centimeters, it will wait for 1 second and then read again. If the sensor reads the distance of the object below 35 centimeters, it will turn on the relay, thus turning on the pump, and the object will be sprayed. And then the program will wait until the object is removed from the chamber. After that, it will read from the sensor again. Next slide, please. These are the circuit diagram and electrical component of our projects. We use 5 main components, that is a 12-volt pump, a 5-volt relay, an ultrasonic sensor, Wemos D1i1 microcontroller, and the last one is the breadboard. The relay and the sensor is connected to the microcontroller, while the 12-volt pump is connected to the relay, so it can be triggered. Next slide, please. And the fourth part will be discussed by Wilnut.
Thank you, Stefan. Now, this is the time you've all been waiting for. Does it work? So in this part, I will explain how the device works, and also solving the problems that we encountered early. This is a simple diagram to depict how the system works. First is arrival. Your order from the online shops will show that your driver has arrived. Second is the run-up. Then the courier puts your package inside the chamber. This way, you don't have to worry about the driver entering your house when you're at home. The chamber also works as storage outside your house to protect your package from rain and heat. Third is disinfection. We wait for the probe from the chamber to disinfect your order. You will receive notification on your phone when it has already finished. And last but not least, you can enjoy your clean and germ-free package. This is the video of one of our tests using the program and a chamber with a tripod as an object.
Ayo, udah, gas. Ambil lagi.
Ada aja ya kan.
Gak ada ya.
Tungguin aja kau cakat.
Yes.
Next is the STEAM analysis, which analyzes the project from 5 different point of views. First is science, where we have our electronics and diagram which connects the sensors to the device. Then we have technology. We know that CPU from 5 to 10 years ago are big and heavy. Meanwhile, nowadays, such as the Arduino that we used, are very small and lightweight. This development technology shows that the developments it decreases the size and the weight and increase the function. The third is engineering, where we use the physics rule of flow rate to increase the sprays and create sprays from liquid disinfectant. The small output and high velocity made the water particles smaller. And the fourth aspect is art, where we design our prototypes carefully so we have a perfect design to come up with. Lastly is math. We learn three-dimensional shapes by creating chamber and use measurements to make sure it fits correctly. Now it's the last part, which is the conclusion. In conclusion, with all stages of testing and comparison to our previous models, our team will proudly say that our device works as expected and our project is successful. However, there are some recommendations that we would like to offer for future developments, which is the material. Instead of using acrylic, steels or aluminum are much more recommended because of the strength and durability. They both are also waterproof and very strong. And that's the end of our project presentations. I hope it is useful and could be really implemented to daily use. Thank you and good afternoon.